Hi everyone, Krishna this side. In this video, I'll be covering this lead code problem 2081, sum of k mirror numbers. Okay, quickly just let us go through the problem statement, what it is saying. A k mirror number is a positive integer without leading zeros that reads same both in forward and backward direction in base 10 as well as in base k. Okay, for example, 9 is a 2 mirror number. The representation of 9 in base 10 and base 2 are like 9 and 1001 respectively. Okay, so which read both same in forward and backward direction. So when we read 9, it is definitely base 10 of this 9 number, and base 2 of this 9 number is basically, this is how we can get these values. So if we read it in forward and backward direction, numbers are same. So on the contrary, 4 is not a 2 mirror number. The representation of 4 in base 2 is actually 100. If we read it in forward direction, it is sounding 100, but if we read it in backward direction, it is going to be 1. So which is not actually same, right? So yes, 4 is not a mirror number of 2. So given base value and this number n, return sum of n smallest k mirror numbers. Okay, we have to get first n numbers which are actually k mirror numbers. Okay, and we got to know what is the k mirror number. Okay, so if we look into the example, k value is basically 2 and 5 numbers are something what we have to figure out, first 5 smallest numbers. So base of any number is going to be the same, and I'll tell you like how we can get of any numbers base values. Okay, so it is going to be the same, and when we try to get base 2 of that number, it is basically this one. So we will keep on checking whether that number's base and that number is basically, when we read it from forward and backward direction, if it is same. Okay, so if we look into this, all this one, basically when we read it in forward and backward direction, they are same. So simply we can consider all these 3 5 uh, 1 3 5 7 9 and sum them up, because all those are the first 5 smallest numbers that we can get it, whose base values when we read it in forward and backward direction, it is same, and even this whatever the number that we picked, it is also same. Okay, so yes, let's first try to understand how we can get it any numbers base values, right? So let us say that we have 9 is the number that we have, and we are asked to get its 3 as a base value. Okay, so let us suppose k value is basically 3, and we are trying to see whether this number base 3, how we can get its base value of 3. Okay, so the first thing is like we will simply start dividing this number with 3. Okay, when we divide this 9 with 3, when we divide this 9 number with 3, basically here it is getting 3. Okay, 3 threes are 9, 3 into 3 basically 9. The remainder what we are getting, 0 is the remainder that we get it. Again, when we divide this number 3 with 3, it is the remainder is basically 0, but here the output is 1. Okay, when we divide 3 divided by 3, it is basically 1. Okay, and the remainder is basically 0. So further this number cannot be divided, so yes, that is going to be the last remainder. So when we read it from downward, it is like 0 1 0 0. So this is actually base value of number 9, whose value is 3. Okay, so 9 is basically the same number, so its base value of 3 is basically this. Okay, so yes, the idea is pretty much simple, right? So for any number, when we are reading its binary values, we will simply keep on dividing that number with the that 2, because base value is 2. So when we divide here, it is basically 4, the remainder is 1. Again, when we divide here, it is 2, here it is 0. When we divide here, it is 0, here it is 1. When we start reading it from the backward, it is like this, how the value is basically in a binary representation of that number. Okay, base value is basically 2 in that one. Okay, so yes, whatever the base value that we get, we keep on dividing that number with that value, and we will keep on collecting the reminders, and from the downward onwards, we will keep on reading those reminders. Okay, so whatever the answer that we get, that is basically the base value of representation of that number. Okay, so we got to know how we get the base numbers. Okay, now the idea is pretty much simple for the brute force approach. When we try to solve this question, okay, we will start from 1, and we will keep on checking whether the number itself is a palindromic number, or when we read that number from forward or in a backward direction, if it is sounding the same or not. Okay, if that number is palindromic number. Okay, so what we will do is we will simply get its base value, and we already saw how we can get the base values. Okay, in the code we will see like how we can get that value, but yes, we will keep on dividing that number, and reminders is something what we have to collect. So base values are something what we can get it, and now the idea is like again check whether this number is palindromic number or not. So a palindromic number is like when we read it in forward or in backward direction, it should be basically sounding the same. Okay, so that's why I'm saying the palindromic number or not. So yes, those base values are something what we will try to figure out, whether both these numbers and that number base value of that number whether they are palindromic number or not. If they are, so simply we can consider it in our sum variable. We will add this particular number, and yes, n value is something what we will keep on reducing. The moment n value is basically equals to 0, we are done. We got all the smallest numbers from having the base value 3 and base 10, and those numbers are basically mirror. Okay, so yes, that is something what we have got from this one. So but the problem with the brute force approach is when the value is actually, let us look into this example. N is basically 17 and base value is 7 is something what we have given. Okay, so first 17 smallest number is something what we are trying to figure out, whose 7 mirror numbers are, like these are the numbers that we got it. Okay, here they have directly provided us. So when we start brute force approach, till this point we have no issues. Till this point also we do not have any issues. The moment we start going and looking for the bigger numbers, okay, like till 17, if we reach for the last 17th number, it is actually really big. Okay, this is actually huge number that we are seeing right over here. So the problem is when we start brute force approach, we are actually trying to see each and every number, whether it is palindromic number or not, and we get its base value and again check. So just to get 17th number, we actually tried processing this huge number. Okay, we go from start from 1 and we keep on checking till this number. Okay, then only the n value basically goes to 0. What if n is basically this n range is actually till 30? So if 30th number, if we want further, how many numbers we have to process, right? So definitely we will going to hit TLE. Okay, we will exceed with the time. We cannot process simply by going one by one and keep on checking those values, right? Some logic we have to apply right over here, correct? So let us look into the screen now. Let us say that we are actually starting from 1, 2, 3 till 9. All these numbers are basically palindromic number. That is clear, because if number is a single digit number itself is going to be same, because when we read it in forward and backward direction, it is going to be the same one. But after 9, it is like 10. 10 is not palindromic number, that is clear. 11 is palindromic number, but 12, 13, 14 till 21, these all the numbers are not palindromic number, but still we are processing them just to check whether the number is palindromic or not. But it is clear that these numbers are palindromic, it is not the palindromic number, right? So next number is like 22. After 22, again we will keep on going, and 32 and 33. In between all these numbers, they are not palindromic number. 33 is the only number that is palindromic number. Okay, so we are getting something like in between these numbers, they are not palindromic numbers, but we are processing them. So just see here, the numbers are like 11, 22, 33 till 99. So from below 100, these are only numbers which are palindromic number. From 10 till 90, below 100, these are the only numbers that are palindromic number. So can we see that with the help of this 1 till 9, can we actually do some string operations and try to generate these numbers? Okay, is it possible to generate these numbers? Okay, with the help of 1, if I consider this in a form of string and get the same number again in front of it, this is basically 11, that is basically a palindromic number. Okay, so this is like a first half of this string, and second half is again the same number, but it is in a reverse format, and that number is basically a palindromic number. So with the help of 2, we can generate 22. With the help of 3, we can generate 33, and so on. With the help of 9, we can generate 99. Okay, so something is getting right over here. So yes, so instead of going through all the numbers, we can, with the help of these numbers, whatever the previous numbers from ranging from 1 to 9, if we use it, we can get all the palindromic numbers till 100. Okay, that is clear. With the help of those numbers, we simply, what we are doing, we are getting the string, we are just appending the same string, and we are getting the answer. Okay, that is something what we are doing now. Okay, what if the answer is basically rank? So n is basically 5, something what they said. From 1 to 9, let us suppose 4 numbers we got, and from 11 to 99, let us suppose 1 digit extra we got. So if we simply getting this answer from this range, we are done, right? So how many numbers we have processed? Just 1 to 9 numbers we have processed, and with the processing of these numbers, we actually got all the palindromic numbers from 1 to 100. Okay, that is the simple idea that we got. Okay, from just simply processing. But what about next numbers, right? Ranging from 100. So further, how we can utilize the same previous numbers? Okay, so let us suppose we are actually looking for numbers who are actually greater than 100, and we are actually required to get their palindromic numbers. Okay, only palindromic numbers is something what we are actually required to get. So what we can do is from 10, from 1 to 9 we saw, from 10 to 99, we again do the same operation. Okay, we again do the same operation. Okay, now here what we do is we'll start from 10, 11, 12, and we will go till 99. Okay, and with the help of 10, okay, the next palindromic number that I can generate is basically 101 or 1001. How it is getting processed? See, this number 10 basically we can write in this direction, and when we reverse this number it is basically 10. Okay, and with the help of these numbers, two palindromic numbers that can be generated, it is like 10 we consider itself, and we can omit this 0 because it is going to be the same one at the end, middle of the, it is basically middle of one. So odd length is something we can generate. Okay, 101 is something we can generate by removing this digit or that number itself. If we, even if we consider this 10 and this reverse number, that way also we can get the palindromic number. Okay, this way we are, what we are doing, we are trying to get both the palindromic numbers considering this is the half length. Okay, so if we want a full length, whatever the number that is there, when we mirror it, okay, when we reverse that number, definitely when we try to merge both the numbers, we can get two different possibilities. The first one is like we can simply remove this one 0 and we can get smallest one or the largest one for that particular number. Okay, these two different numbers we can generate. Okay, for 11 it is going to be again 111 or 1111. For 99 or 98, and then there is a 99. So for 98 it is 90989 and 9889. For 99 it is like 999 and it is like 9999. Okay, so yes, when we are actually of having length 1, when we started with length 1, okay, length 1 means like 1 2 3 till 9, this digits length is basically 1. Okay, so how many numbers we are covering? Length 1 as well as length 2, all these digits basically covering. With the help of 1 2 3 9, we either can get 1 or 1 1, we either can get 2 or 2 2. Okay, this way like we are considering all the numbers from 0 till 99. Okay, from 1 till 99, all the numbers that we get 1 till 99, all the two length of numbers that are palindromic numbers, those numbers we are basically directly retrieving it from just 1 to 9, processing 1 to 9, from 10 to 100, 10 to 99. Okay, 1 to 9 is basically covered from 10 to 99. If we again traverse, if we again traverse, the digits that we are covering is like 101 to 9999. Okay, so what is this length? Like it is length of 3, whatever the digit length 3, which is actually palindromic number, all the numbers basically been covered with the help of this 10 to 99. Okay, and this digit of length 4 is also been covered. Okay, so with the help of length 1 we are covering length 1 as well as 2. With the help of length 2 we are covering 3 4 length. Now with the help of length 3, let us suppose from 100 to 99, all the palindromic numbers having length. Okay, this is the first one. Okay, or this is the second one. Okay, so it is like again here also, and this is the last one. Okay, having length 6 and having length 5, all the digits which are actually palindromic number, those actually getting processed with the help of this 100 to 99 digits. Okay, so what we are doing, we are just basically with the help of this 1 to 9, we actually get all the palindromic numbers, only the palindromic numbers. Okay, doing a simple operation with the string manipulation, we can easily generate these numbers. Okay, we got all the palindromic numbers. Okay, till below 100. With the help of 11 to 99, we got all the palindromic numbers from 101 till 9999. Okay, of string of length 3 to 999, that is like length 4. Okay, this way we are actually covering all the different lengths. Okay, 4 5 has been covered with the help of 100 to 99. Okay, next palindromic number, so it is like we are just simply generating the palindromic numbers, and apart from these numbers we will not going to get any other palindromic number in between that. Okay, so yes, now simple idea is we simply from one of having length 1 and having length 2, all the palindromic numbers, this is something what we got. Now we can simply check its base values and check whether that number is basically palindromic number or not. If the base value of that number is actually palindromic number, we simply reduce the ns value, and in this particular range, if the answer is not relying, whatever the range that we actually got, in this particular range if answer is not relying, we will start looking from this one 100 to 99. From 100 to 99, total numbers are 90. 90 for all these 90. The next palindromic numbers that we are covering is of range from 3-digit number till 4-digit number. In this one, we are actually covering all the numbers. Okay, just by processing these 90 numbers or 89 numbers. Okay, simply by processing 89 numbers, we actually got all the palindromic numbers ranging from 101 to 9999. When once we got all those palindrome numbers, we simply check its base values and we keep on getting the answer. That's how we can write the code. It is pretty much simple. So what we are doing, we are just trying to generate the palindromic numbers. Now in this particular range also, whatever the palindrome numbers that we got, the answer is still not getting. The next range is going to be 100 till 999. With the help of this 100 till 999, we can get length of 4 and length of 5. Okay, and those this length of 4 and length of 5 are basically palindrome numbers. Okay, so yes, keep on doing this one. Now if the answer is still not lying in this range, the next one is like 1000 till 9999. All the numbers that are there, that is like a half length. With that number we can generate two different combinations, and all those numbers are basically palindromic number, and the length of all those numbers is like length of 6 and length of 7. Okay, only we are directly focusing on the numbers who are actually palindromic number, and we will basically check its base value if it is a palindromic number or not, and based on that we are simply solving this question. Okay, the idea is pretty much clear. Now let us try to write down the code. So let's say if you get the idea, you can start writing the code. Let us say that the first thing that we will do is we will get length variable here. So length is basically starting with 1. Okay, and we are keep on increasing the length. Okay, for length 1 we are basically covering from 1 till 99. All the palindrome numbers is something what we are covering. I'll run a while loop here simply and keep on reducing the cn's value. The moment if any number is basically palindrome number and base value is basically palindrome number, so n is actually greater than 0, n should be basically greater than 0. Now that is done. The first thing is like we need to get the range. Okay, so what I'll do is I'll run a for loop. Okay, for int or else what we will do is instead of this length, let us name it as a half. Okay, for half basically it will start from the 1 or the whatever the value is there. uh Let me name it as half. If it is half, it is fine, right? So let us start this I equals to from this half, and I should be less than half into 10. Okay, because that is the range that we are covering. 1 to 9 is basically the numbers that we are covering. After 1 to 9, the half should be jumped from 10 to 99. That way we can generate all these possibilities, and I plus plus is something what I'll keep on doing. Okay, that is the basic simple thing that we have done. And yes, once this for loop is done, we will be able to get all the numbers from 1 till 99. Now the half should be focused in this one. If we did not get any palindromic numbers which are basically following this one, the next range should be from 10 to 99. With the help of 10 to 99, we will try to generate all the palindromic numbers which are of having length 3 as well as having length 4. Okay, so at the end half should be getting updated with half into 10. So basically it will start from 10. Okay, half is initially 1, 1 into 10 is basically 10. In the next loop it is like 10 into 10 is basically 100, from 100 to 99. Okay, half into 10 is basically it will like 10, it is multiple of 10 only, right? 10, 100, or then it is like 1000. So the basically as range is basically relying in that one only. Okay, in the first for loop what we will do is let us get this number in a form of string. Okay, we are not required to get these numbers in a form of string as well. Okay, we can solve it without help getting taking help from the string. But yes, just to get a clarity, I'll be writing out the solution in the form of string, and you can further improve the solution. Okay, the first thing is like I'm not interested to cover the middle element. Okay, from whatever the string that we got, when we try to reverse it. Okay, and then we keep on merging the strings. That was the logic that we were doing it, right? The first thing is like let us convert this string. Str is something what the name I'll give, string dot value of this I plus. Okay, we will simply reverse the string. So how we reverse this string? I can create a string builder here, new string builder, whatever the str dot value of I is something that we have. Okay, uh other is what I'll do is whatever the value that I got, here string, it is like a palindromic string or not, that is something what we have to check. Val is something the name that I have given. New string, here what I do is str plus new string builder, I just added that string, then just reverse this one. Okay, once we reverse it, we got new string in a reverse direction. So let us suppose we have one. So once reverse is basically again one. Okay, one is something I have added, one again I have added, but now whatever the last digit, that is the starting digit that is there, I actually don't want to consider it. Okay, so in that case, once we reverse it, after reverse, whatever the string that I got, okay, that string I want to start reading from this first index. Okay, now substring is something what I'll add it here, function substring of one. Okay, from one it will be start reading it. So this one is basically get removed. Okay, in the first case. Okay, so that way we got a string initially. Let us suppose what it is basically doing is like, let's suppose a big number is there, 12 is something what we have. Okay, for 12 this string is basically 12. So in this palindromic string, 12 is something that I have added. Now I have used string builder to reverse this string. Okay, so whatever the 12 is there, so reverse of 12 is going to be 21, and I am reading this from 1. So this whatever the two values there, it will get removed. Whatever the merge string that we got is going to be the palindromic string. Okay, that is the first case. The second case is like I don't want to read it from the substring. So whatever the value is there, reverse 12 is something that there, I simply want to merge it. Okay, that is another case. So simply it is basically asked to get the smallest numbers. Okay, so basically first for loop we will run, and we get the whatever the middle element. By removing that middle element, we will try to check whether those numbers are palindromic number or not. Sorry, the whatever the base values of those numbers are palindromic number or not. That way we try, we will still we will get all the smallest numbers. Now the next numbers are like ranging of having length 4. Okay, that is something what we will keep on trying. So two times I will run a for loop, and both the times I'll do the same operation, but here instead of reading it from the 0, I'll read it from the starting index. Okay, this way like it is going to be 12, 21 is the value that we can get in this particular for loop. Okay, now we got the palindromic string. I actually want to get this whatever the base value of that particular number string, whatever the string is there, we want to get the base value, right? So let us name it as a val, and get to base k. Okay, whatever the get or else to base k is something what I can name it, and pal this string is something I can pass, and k value is something we can pass. This what this it will return, it will return the value of that number to the base k, and I actually want to get it in a form of string. Okay, this whatever the value that we are getting, that should be getting in a form of string, so that again I can check if this whatever the value that we got, if it is a palindromic number or not. If is palindrome, okay, is palindrome is something I create a function, value is something that I'll pass right over here. If it is a palindrome, we simply add it into the sum variable. Let's add this whatever the number that we have currently, the I number, we simply add it. Okay, and the moment we add it, let us create here the sum variable as well, sum equals to 0. The n value should get decreased. Okay, n minus minus something what we will do, and there should be another condition right over here. So we will keep on checking if n is basically going 0 or not. Okay, that was another condition. Now the same thing is something what I actually want to do, and we have to perform this two different functions, like get to the base k and is palindromic number or not. Let me copy this code, or what I'll do is here this value is something I'll keep inside here, and yes, I can remove this extra whatever the things that we are getting collected. So this way we are done. Now after this for loop, we will check again whether this m, if n is actually equals to 0, then we can break from this loop, because we got all the numbers which are palindromic from that above for loop. Again I can do is, what I can do is, I'll just copy this for loop and I'll paste it right over here. Okay, but here the substring should be reading it from the 0, or we can remove this substring function instead. Okay, so yes, that is the all idea that we have right over here. Let us create this is palindromic function first. So it is like returning boolean, so boolean is palindrome. Okay, and here we are getting a string. Let us suppose yes is the string that we have. So the first is like we will use two pointer approach, I equals to 0, j equals to basically equals to s dot length minus 1. Okay, and we will keep on checking whether this I is basically less than this j, and both the values should be matching, the first and the last. If they are matching, so we will reduce this j value and increase the i's value. Okay, if at any point in time yes dot char at I, if it is not matching with yes dot, okay, yes dot char at j, if that is not happening, we will simply return false from here. Otherwise, if we reach to this condition where I is greater than j, that means that string is palindromic number, so we return true from here. Palindromic number is something we have defined right over here. Now to base k, okay, this is something what I'll define right over here. So it should return a string, so let's name it as a string to base k. Inside here we are getting the first is a string argument, string s, okay, and the next one is like the k base value. Okay, so the first thing is like I need to convert this string into the long. Okay, long val is basically equals to s dot what is that long. Okay, it is actually lagging. It's parse long. Okay, here I can pass the string, so that we will keep on dividing this whatever the value that we have, and we'll try to get the reminders. So to get the reminders, I'll create here a string builder. Sv equals new, okay, and we will keep on appending the reminders. Sp dot append val modulo k. This way we get the reminder, and this val should be getting divided with this k value. Okay, once this is done, we will simply return sv dot reverse, okay, dot to string, because whatever the value that we are covering, we are going from top to bottom, whatever the reminders that we are getting, but we actually are supposed to go from down to upward direction. Okay, so yes, we have to reverse that string and we have to return it. Two base case also we figured out, and we are checking this whatever the string that we have generated, it is basically a palindromic string. Okay, no doubt in that particular one, so we are not required to check whether this is palindromic number or not. We simply are required to check whether this whatever the number that we got, if its base value is palindromic number or not. If it is, so we simply consider that number. If not, yes, we are not doing anything, we will keep on increasing this loop. And these all values, this for loop, let us suppose, let's take with an example, start with an example. Let's say we are starting with 1. Okay, the half is basically starting with 1, and it is this first for loop is going till 10, and I is basically increasing, so it is like 1 2 3 4 5 6 7 8 and 9. Okay, these numbers are something what we are checking. So this first for loop, what it is doing, so we are getting this number in a form of string, and we are reversing the same number. Okay, and while merging this string pal, we are actually reading it from the whatever the second reverse string that we got, we are reading it from the first index, so this basically get removed. Okay, one is something what we will get. So same happens with 2 3 4, and we will keep on checking whether the number is palindromic number or not. So this, that is the first operation that we have done. The next one is like whatever the reverse number that we are getting, we are simply merging it, so it is like 11 2 for 22. So this particular for loop. Okay, so here whatever the reverse string that we got, we are simply merging it into the string, and the string is something what we are getting. So this palindromic string base values are something what we will keep on getting, and we will keep on checking whether the numbers are palindromic numbers or not. So the moment all these values are been checked from these two for loops, different for loops, we, if the answer is satisfied, if n value is actually equals to 0, we are done, we will break out of this loop. So we will simply return the answer. So answer should be sum. Okay, sum is something what we have to return. Okay, did I, no, it should be outside of this one. Okay, yeah, here is the sum that we will return at the end. But if the answer is not lying in this range, what we are doing, the half, whatever the half that is there, here this is the first for loop, here it is the second for loop. After this, the half should get increased into 10. So currently half was basically 10. Half was initially 1. Okay, half length, okay, that was 1. So now from 10, okay, half basically got increased from 10, where we are going 10 into 10 is basically 100, so 10 to 99, all the numbers that we get. Okay, 11 12 13 14, okay, so on till 97 98 99. Okay, with these numbers, what we are doing, same operations we are doing. First we get the string, we get that strings reverse. Okay, 11 is what the value, first value we have. Then again the reverse of that string is like basically 11, and when we do this substring of 1, this 1 will get removed. So that is the first thing that we get. Okay, next is like for 12 it is going to be 1 2 1, for 13 is like 1 3 1. Okay, and so on, it is keep on going. For 99 it is 999. Okay, this is the values that we keep on getting. So we will check whether these numbers are palindromic number or not. So if these numbers are palindromic numbers, we will add it into the sum and we will keep on reducing the n value. Okay, these numbers base values are something what we are checking whether that base value is palindromic number or not, because already these numbers are palindromic numbers. We are simply generating with the help of these numbers. We are simply generating the palindromic numbers. Okay, now once this smallest range is done, we will try to see length of 3. Okay, so 11, this second for loop, it is basically doing that operation. We are simply adding this 11 into 11. We are not reducing that one value. So next is like 12 1 2 1. Okay, this way we are actually getting smallest values. The length of 3, length of 4 is been done. Then the next range is again, if in this particular range also the answer is not satisfying, the half will get increased from 100 to 999. In between that range, all the numbers, palindromic numbers, next palindromic numbers is something what we have to figure out, and we are done. Okay, that way we can get it. Let me run this code. So it is actually medium level problem if we think about it, and simple operation is something what we are doing. String dot value of. Okay, and is there any other error? Okay, in the here also we copied it, right? String dot value of. Let us run this code again, try to see if it is working fine or not. This n's condition should be matching every time because we are keep on reducing it and we don't want to collect extra functionalities. Okay, it is actually time limit exceeded, so we have to see where we went wrong. Okay, I don't know what has been happening here. So half is basically 1, so started from 1 and we are going till that one, and I value is basically having range from half into 10. Okay, so the first for loop keep on going. We get the reverse of the string palindromic number base sum is basically we are adding it, and n is something got reduced. If n is actually equals to 0, we will break from this one. Otherwise again we start from the half into 10, but this time we will get the even or odd length string, and we are checking whether it is a palindromic number. Pal and that sum is something what we got, n minus minus something that is happening. So if that is done, half get increased, half into 10. So we in this particular for loop only, is half is basically getting incremented in the same for loop. So why is the problem? Where is the problem? Can we see if we are doing any mistakes in this one, writing this one? Value is something what we are checking whether it is actually greater than 0. We pass that whatever the string that we have passed, and string builder where we are appending these values. Value equals to val model k, and value got updated. What about here? Yes, here in the palindromic string we have to increment this and we have to decrement j. I guess that was the mistake. Okay, apart from that I don't see any other mistakes right over here in the code. So the answer for this one is 66. The output is expected wrong. Just let me debug it. Okay, I don't know what mistakes I have done. Okay, I got the mistake. I am actually adding this half value. Okay, it is actually half value, whatever this value. The palindromic string that we are checking whether this value is basically a palindromic number or not, that value is something what we have to add it into the string. So yes, we have to get long here, long, or else let me copy that operation is something I have done right over here. Instead of doing right over here, let's pass here value itself, long val, and in both the places what I'll do is I'll get that value here, and this value is something what I'll pass, and this should be updated right into this one as well. So value is something what we have to add it. Okay, just make sure you are writing the correct code. So I'll paste it, I'll just remove this line. The value is something I actually want to add it instead of I. Okay, so yeah, that's it. Like whatever the value that we have generated, that is something what we have to add it, not this half value. Okay, the naming can be better. I just have written a random code, and instead of writing the for loops also we can improve the code a much better way. That is the task that you can perform right over here. The idea is I just want to make sure that I'll be explaining the code in proper way. So it is not again the, yes, it is a pal. Okay, and here also it is a pal. Okay, that is the string that we're trying to see, right? So yes, you can reduce the code redundancy, whatever the duplication of code that is happening, you can reduce it further. And also, instead of using the strings, you can basically get without the strings also we can process it, okay, by dividing the numbers and getting the reverse of those numbers and all. Yes, those operations you can try perform, and you can improve the code. The main motive was to explain the code properly. Was this is like starting from the whatever the smallest numbers that we get with this whatever the half range that we have, and then there is like another, if we do not consider that reverse, that way also whatever the numbers that we get, based on that I'm just collecting the answers, okay. Yes, this code can be further improved. And talking about the complexity here, it is going to be actually, see, the complexity is a bit weird discussing right over here, because we are doing some t kind of operations. Let us suppose we are starting from the range 1 to 10. Here the possibilities are like 10 into 2, 20 palindrome numbers are something what we will get, okay. When we start range from 11 to 99, difference is like 89 or 90. Let us suppose 90 is the difference that we got. The 90 numbers, parent drawing numbers, those are like it is going to be 90 into 2, okay. That way we are actually getting it. So this is whatever the values that we are getting it, those are like t operations. Let us suppose the t operations is something what we are doing, and t value whatever we are doing those operations, okay, it is basically going to be less than this whatever the value that is given, n value, okay. That is going to be happen for sure, okay. So n into whatever the this 2 base k, okay, 2 base k, this particular function is something what we are trying to solve. This is basically going to take log of n time, because we are keep on dividing this value, okay. And we are getting it. So that is like entirely, if we discuss the entire complexity is 2 into n log k, okay. So n log k is the base value that is there, and to the power of n, okay. So it is like n log n, something that you can consider to solve this particular problem, okay. And yes, it can be further improved much better way, and that is up to you. So now you got the idea, so you can further improve the code. The video is going to be pretty much lengthy if I again try to cover those things. So yeah, that's all from this particular video. Thank you for watching this one. Bye bye.